Hello once again, this is Greg Sass, and I'll be going over my lesson plan for geometry. And this is the best way I can figure out how to make screencasts, as my computer will not allow the downloader to work. So I'm going to focus on the side-by-side comparison of the two lessons. Here I have my original and here's my revised version. As we can see, my field supervisor will be Mary Sullivan, so she would be very familiar with this type of approach using a POGO lesson. My title and the standard and central focus didn't change. The only thing that really changed was the academic language, and that was really more of a formatting issue and a simplification. So the review felt that perhaps I had, by writing it out into paragraph form, it didn't give the same feel as breaking it down as it would in bullet form, so I changed that to bullet form, and I also eliminated review words from the vocabulary, which perhaps would have been a review from a much earlier lesson than just the one before. So I focused just on the words that would have been given from the day before. And then I only have one new term, and I bolded that so that it's easier to understand that I'm only introducing one more term in this vocabulary. And then I also added some of what the students would be doing, so that it was much clearer as to, although what the teacher was doing, the students are also already directed based on the POGO lesson to do certain things, and so I added those comments in there as well, so that it's clear as to what the students are doing, where the students are the ones who are exploring and breaking things down and trying to come up with that explanation and not so much an instruction. So I'm going to go ahead and eliminate the old and expand to the new here, and we'll enlarge this here, and I will just go through what we have here. So I already talked about the title here is a play on the postulates being the side angle side, or the angle side angle, or the side side side, and then throw in with my name. And so I had some fun with that. The standard comes from the congruence lesson of B8. Explain how the criteria for triangle congruence, angle side angle, side angle side, and side 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 follow from the definition of congruence in terms of rigid motions. Central focus comes from the letter C, where we translate quantitative or technical information expressed in words into a text into visual form, and translate information expressed visually or mathematically into words. And so we're focused on that latter half of the central focus of getting the mathematics into words, and thus my verb being explain. Explain being defining necessary terms involved, compiling the information from the model, analyzing the data, and composing an explanation that justifies the resulting declaration. Language supports, we're going to first start by recalling the definitions of the vocabulary previously introduced in the congruence lesson, and then give the definition of postulate. Here's the vocabulary list with the new terms being bolded. Congruence, figures which are equal in shape and size, segment, a line fragment defined by two endpoints, angle, a figure formed by two rays with the same endpoint, triangle, polygon with smallest number of sides, being 3, rigid, a body in which the distance between any pair of points remains fixed under all forces, and postulate, a set of statements accepted without proof within a particular area of study. Our discourse vocabulary review at the beginning, where students will provide the definitions based on previous lesson. POGO lesson to introduce the concept with the model that guides them to the explanation of the SAS postulate. The syntax, we have the individual statements of mathematical representations from the given models, such as which segments, angles, or triangles are congruent. And the macro is that information being organized into mathematical proof in paragraph form. So our learning target, I can explain how the SAS postulate shows congruency by defining congruent portions of triangles and compiling the information into paragraph form. So once again, we start with the review of the vocabulary, the students giving the definitions for that which was previously given, and then I would introduce the last term of postulate. Also, in preparation for this, we've made an informal assessment based on our feedback from the last POGIL lesson to see who was strong in which roles, and see if, as we rotate those roles, to see if those students continue to remain strong and who's weak, and so we can keep the groups balanced. And so that will be one of the focuses while I am monitoring the POGIL lesson. So we have the POGIL lesson on congruence postulates. Module 1, 2, and 3 takes each of the postulates individually, so we're focused on just Module 1, which is side angle side. The lesson will guide them to identify congruent parts of different triangles and have them attempt to explain why SAS is a valid postulate for congruent triangles. Break them up into previously assigned groups from the previous lesson and rotate roles so that everyone has a new job. Focus observations on their answers where they explain SAS validity marked by the key symbol. Intervene only if they appear to be stuck, and have the group send a spy to another group that has progressed beyond the key point to help them get unstuck. And so here's a further explanation. Students will explore the model to determine what is congruent, recognize the pattern side angle side, and create an explanation as to its validity as a postulate. As part of the instructions to the POGIL activity, which will be on a PowerPoint slide, which is typically how we do that, we have the PowerPoint slide instructions, and after the stop symbol, the students will report out from the POGIL activity where groups swap spokespersons to share their results with another group. And so this gets the discussion going within between the groups, and then have them at the end of the POGIL activity reflect and write down what was difficult for them during the activity, so we can capture that feedback while it's fresh in their mind. And then at the end, I would have the spokespeople come up and help us to combine the results of the POGIL activities for each of the groups in order to come up with a class explanation, and thus as a class explain why the SAS postulate is important. Make sure we get everyone's concurrence, and then reinforce the definition of a postulate, trying to show that in this case it's so obvious we don't have to write a formal proof, it is just accepted. And so the students will discover that. And that's all I have for my lesson, and hopefully I'll be able to use this lesson at some future point with 9th graders in geometry class. And I hope to be able to continue to also create POGIL lessons to keep this open forum going, and have students be able to understand and discover for themselves this information rather than just straight lecture. And that's all I have. Thanks.